Hi and welcome to this fourth video in the series, looking at the different synthesis methods in Parawave Rapid. Please check out the earlier videos in the series for an overview and a look at traditional subtractive and wavetable synthesis, along with FM and granular synthesis using Rapid. This video will concentrate on Rapid's implementation of Resynthesis. Rapid's tooltip describes the process as extracting the spectral magnitude of an input sample and resynthesizing multiple perfectly looped and similar sounding samples for different pitches. So let's have a look at this in practice. To illustrate this, I've placed a number of samples into Groove Agent so we can more easily hear a before and after the resynthesis process. So let's start off with a hi-hat sound from the Akai XR10. Let's have a listen to the original sample. And let's have a listen to the end result. So you'll notice that the attack and the decay characteristics of the hi-hat are gone, and we're left with the spectral characteristics of the sound, perfectly looped. Now we can mimic the percussive nature of the original sound, of course, with the use of an envelope. So if I take the decay down and, the sustain down, and adjust the decay, we can sort of go from a closed hi-hat sound to an open. But that's not really the point of resynthesis. Parawave suggests that monosamples work best from 1 to 4 seconds, but keep in mind though that you'll get a spectral snapshot based on the duration of the sample, so that different pitches will result either in a chord or a cacophony depending on the source material. To show this in action, here are 3 piano notes. And when I put this through the spectral process, the end result will give us a chord. I think you've probably worked out by now that resynthesis lends itself well to the creation of textures, so let's have a listen to a few more examples. I genuinely can't remember where I got this particular sample from, but the resulting texture sounds like this. Again, perfectly looped, so that would work very well in a pad, perhaps just underneath the main oscillators to give it a bit of interest and movement. This is quite a famous shakuhachi sample. I think it originated on the EMU emulator. I got it from my Akai S1000 library. Let's have a listen to the original sample. And the resulting texture in Rapid. The same sample disc on the S1000 came with this sample of a bird. And again, put through the resynthesis process. We'll take an example of some speech now. Don't know who this guy is. Parawave Rapid. And we'll have a listen to the end result. This old S1000 sample of a guitar sounded like a nylon string. Gives this result. That initial pluck of the sound has been softened. The frequencies are there, but it's in the frequency as a whole, so you're hearing the whole spectrum analysis. You can bring that out with an envelope, but again, really the aim, I think, of resynthesis is more to create textures. A reasonably legitimate use of resynthesis might just be purely to achieve a perfectly looped sample that would otherwise be hard to loop without extensive crossfading. This example, Rainbow 1, is a snippet from the Rainbow Dome track I used in the granular synthesis video. So perfect looping without having to get into crossfade loops. Let's have a listen to another example from the same track. Rainbow 2, this was a different section of the same track. Just before I play the final piece, we're going to have a look at 1 or 2 individual patches to illustrate the power of resynthesis and the power of Rapid. Have a listen to this choir patch created with what was originally a single sample put through the resynthesis process. The resulting multi-sample I have set to a unison value of 8, so a maximum unison on all 3 voices. I've set one an octave higher and one an octave lower, and this one's pitched 7 semitones down, so it's a fifth below, and just a touch of reverb. So let's have a listen to the choir sound. Remember, this is from a single sample. What I'd like you to do though is have a look at the effect on the CPU of this. I'm playing a 3-note chord with an octave bass, so that's 5 notes in total. So we're getting 120 simultaneous playback voices with a CPU of only 2%. Now then, to further refine that choir sound, I'm going to put it through a formant filter, which is set to sort of an R-type sound. And we can get this result. Remember, the original sample was recorded at C3, a single sample, and when put through the resynthesis process in Rapid, the end result is a multi-sample perfectly looped across the keyboard, which I'm free to put through all the synthesis processes within Rapid. This is the resynthesized signs pad that I created in the earlier video. Again, each voice has a unison, is set to a unison of 3 with quite a wide spread, a slight detune, +10 and -10, and I've got a bit of gentle modulation going on the second filter, just to give this sound. This is the resynthesized pan flute. As it's in Rapid now, I can apply, for example, portamento to the resulting multi-sample created through the resynthesis process. So now let's have a listen to the completed piece. Well, I hope you found the series of videos on Rapid useful and have gained an insight into the power and versatility of Parawave Rapid. If you haven't already done so, please consider subscribing, as it helps me to make further videos. All that remains is to thank my existing subscribers, and until the next video, thanks for watching.